This is Suvarchala working as an associate professor in the Department of Computer Science and Engineering in the Institute of Aeronautical Engineering. In this video, I'd like to explain how a case study can be designed completely. A database based case study will be designed completely based upon the requirement specification. So, university system, I'll take an example here and I'll consider informal description of any university administration as well as based upon this informal description, how the logical database model is going to be generated, how physical data model is going to be generated, and the schema and also certain queries. Based upon this, this can be extended by developing some application programs also, either in any host language or in PLSQL also. All are possible actually. Now, I'll go into the case study today. Now, the case study is related to the university system. And in previous lectures, in the beginning of this course, database management system course, I explained already how a database is going to be constructed, what are the steps involved actually. For any given specification, first we have to analyze requirements. Requirement analysis has to be done by us. Based upon the requirements, logical model has to be developed. Logical model, for a logical model, we discussed already, entity relationship model was discussed. But today we'll design a logical model based upon the IBM DB2 model. All are one and the same, almost notational differences will be there actually. So I won't much discuss about the theory related to this development of the logical model actually. Then from this logical model, we have to use some normalization techniques and we have to design a physical model actually. So I'll explain what is the physical model for this case study, but I won't consider the rules and regulations of normalization which already discussed in previous lectures. And then this physical model is going to be converted into schema definition, that is by using any commercial query language, either SQL or DB2, whatever it may be, we will implement our database. The database which we implemented based upon which certain interactive queries were also planned in this session, but the application programs were not included in this session. We'll discuss those application program development in some other session in any host language actually. Fine. What is a university? An university system informal description I'll explain. This was given as a case study for us. Let us assume that ABC University is a large institution with several campuses. Each campus has different name, address, distance to the city center, and only bus running to the campus. Each campus has a club. You observe while studying this description of any case study, we are supposed to note down about which the data has to be stored. So that what happens, it will become easy for us while developing our or identifying our entities and attributes, etc. As a part of that, an university consists of several campuses. So that's why we need to store about each campus data. So that's why campus information is required. What is the campus name and its address, etc. Each campus has a different name, address, distance to the city center, and the only bus running to the campus, etc. So that's why I need to consider campus as one of the entity set or relation in which the data has to be stored further. Then each campus has a club, the name of the club, building in which the club is located, the phone number of the club, and the multiple sports which club offers should also be recorded. So about the club we are supposed to record it, no? So that's why club might be one more entity set. So I made it as a red color. You just observe. Then about the club, as well as club is offering or providing multiple sports offers. So that's why what are the sports are provided and how these sports events are organized, and also how the registration into the sports can be considered. Everything has to be recorded by us. So that's why about the sports also we are going to store the data. So campuses, club, and sports. About these data we need to store up. Next, the university consists of number of faculties, number of department, in other words, such as arts faculty, science faculty, and so on and so forth. Actually, so about each faculty, we have to store the data. That is where that particular faculty exists. That is name of the faculty and dean and building location, etc. So that's why this must be one of the entity sets. The faculty may be divided into number of schools. So about schools also we have to store. So that's why that is PG school, UG school, etc., etc. Science faculty has a school of physics, school of chemistry, and engineering faculty may be having computer science and engineering, etc. So each school belongs to a faculty, one and only, one faculty only, and is located just in one campus. So no school is going to be considered as belongs to the more than one faculty. So all these things we supposed to remember so that association can be easily identified by us among these entity sets actually. So that's why we need to store faculties. We need to store about schools also actually. Fine. Every school has name and building assigned. So each school offers different programs. So what are the programs offered by each school must be stored by us. So that's why we are going to consider the programs offered by each school is going to be recorded. So that is program means UG program, PG program or MTech or etc. So that's why each program offered by school must be noted or recorded. It will have any code, level, title, duration, etc. And each program consists of or comprises several number of courses. That is, once the program is there, the program is going to be registered, completed. To complete that particular program, a student is supposed to undergo some courses. So different programs have different courses. So that's why we need to store the data related to course, which are the courses offered by the respective programs also. So each course has unique code and course title will be there, and some more information might be there, credits, etc. Course may have one or more prerequisites. So prerequisite also another course. So that's why this is a specialization of course we can consider. Course can have prerequisite. Courses have a relationship with itself as a prerequisite as a one of the courses. And one course can be prerequisite or one or more courses can be prerequisites for some other courses actually. So what is prerequisite? Prerequisite is also considered as a some of the courses only which supposed to be completed before registering for some other courses. So that's why this prerequisite is going to be considered as again courses. So prerequisite is also some special case of course. In other words, we can say course is connected to itself with a prerequisite relationship. That is unary relationship. And the next is the students. So that anyway students data must be stored, recorded. So that's why students is enrolled in a single program and involves in a fixed core of courses specific to that particular program, and also number of electives taken are offered by the same program or other programs also, right? So all these courses must be completed by a student, and a student will register and attend the classes and so on and so forth happens in any educational programs actually. So student work on course and are awarded a grade. So student awarded a grade in any of these courses, he or she passes or completes the course actually. Otherwise, student has to retake that course. That means we need to store student information. We need to store their grade information also. Courses and grade they have got actually. Needs to record year and term in which the course was taken and the grade was awarded to the student. So that's why we supposed to consider every student has a unique ID, and what are the courses which are the courses enrolled by the respective student must be stored by us. So that's why we have to keep track of a student information as well as their enrolled course and related grade also must be stored actually by us. So these are the things to be recorded by us actually. And Coming to the employees, the school employs lecturers to teach students, and a lecturer allowed to work for one school only. So, if a lecturer belongs to, teacher belongs to only one school, each lecturer is assigned an ID which is unique across the whole university. The system keeps lecturer name, that is, lecturer details must be stored. And a supervisor may be in charge of several lecturers. Supervisor, in some organization, we'll call it as a coordinator or a head of the department, etc. So that's why a supervisor may be one of the, he or she is one of the lecturers only, but considered as a supervisor for a group of lecturers actually. However, lecturer reports to only one supervisor, and a lecturer will be under a single supervisor only. A lecturer can teach many different courses. At the same time, a course maybe have been taught by multiple lecturers depending upon the number of the, or depending upon the enrollment numbers actually. So this is the basic definition of or basic information or a problem statement or a case study given to us for which we supposed to design a database actually, right? So now we supposed to design a database for this university system actually. So what are the things we considered till now? And this university system consists of the data related to the data related to campus, related to clubs, related to sports, related to faculties, schools, programs offered by the each school, and courses under each program, prerequisite related to the courses, about the students, and enrolled for or registered for certain courses. No, that enrollment information, completed courses, grade information has to be recorded by us. And employees, basically we are not considering the non-teaching, only lecturers, employees, and these lecturer employees are, one of them is supervisor. In addition to that, university is generally here operated by a set of committees. So this committee is nothing but it is a group of lecturers forms a committee actually. Various committees will be there, and the committee's responsibilities are already specified. So the committees are going to be running the entire university academic programs actually. So a lecturer may be a member of one or more committees. There is no any restriction depending upon the lecturer, qualities and capabilities, as well as academic qualifications, etc. There may be more members of more committees also actually. The frequency is determined. The committees meet regularly and weekly or monthly, etc. So that they'll chart out what are the uh, things they have to do further actually. So a lecturer may be, all committee members are lecturers only. Lecturer may be a member of more than one committee also. So this is the description given to us for a university information system. So we need to design a logical database first. So various relations we identified, or various entity sets we identified, you observe here. So the base entity sets are course is the related to the program, lecturer, student, school, faculty. Okay. Now, you observe here, university consists of, first some schools are there. So what are these schools? These schools will have various faculties, and each various campuses. Our universities are having various campuses. Various campuses are going to be having number of schools. Each school will have number of faculties, and each campus will have some sports, club, etc. So whenever we are having such type of processing here, we need to store each campus is having one club, and various number of sports are associated with this club actually. So we have to store the data related to this information. These are connected logically. How these are connected logically? You observe here campus. Each campus is having multiple schools. So you observe here campus to schools is a one-to-many relationship. Each campus will have one club, so one-to-one. Each club offers multiple. So you observe this is multiple, many. So one-to-many relationship between club and sports. Each club offers multiple sports. So that's why this campus is going to be associated with one club. Club is for offering multiple, so one-to-many. Coming to the school here, multiple schools are there. No, each school have multiple faculties. So science, faculty of science, faculty of engineering, etc., etc. So you are going to have faculty and schools are going to be connected with again multiple one-to-many relationship. Now, here the faculty is going to be connected with the various committee. Each faculty consists of various committee because university is running by various committees actually. So that's why each faculty is having various committees. Each faculty means, in other words, you can say department. Each department is having various committees. So that's why one faculty, multiple committees. But that committee belongs to that faculty only. But remember here, the committees are there. How these committees are comprised? These committees are formed as a group of lecturers. So that's why each school is having multiple lecturers. So that's why one-to-many, because each lecturer can work only in one school. So that's why school to lecturer relationship is one-to-many. And I told you already, lecturer to lecturer, one unary relationship is there. What is that? It's having supervisor or HOD, etc. For that only this relationship was maintained. Lecturer to lecturer, one more relationship was maintained actually. Right? Now, these lecturers are going to be members of the committees, committee lecturers. So, one to multiple committee lecturers will be there actually. Relationship. This is related to the process of our entire respective schools, campuses, and the administrative process of the or academic administration of the campus actually. Now, this is related to the running of the program. But what happens? We have to offer some courses. Courses must be registered by the students. So that's why here your school is having multiple programs. One-to-many relationship. Each program must undergo certain courses. So one-to-many again, each program, multiple courses have to be registered under each program. And what is this course? Course is going to be having various types of relationships. That is, course itself is a prerequisite. Course is going to be taught by the lecturer. So this is a relationship between course and lecturer. Lecturer course is a relationship here. And course is going to be enrolled by students. So course student is a relationship here, which is an entity set again, or relation again, because many to many, no, that's why. Then prerequisite. Each course will be having multiple prerequisites actually. So remember that here we are connecting course to prerequisite, prerequisite to course. Because course itself is having some prerequisite. Prerequisite itself is a course again. So that's why actually. Now, by observing this logical model, here we are not at all constructing any ER model and we are converting it into logical model. Directly the logical model was developed actually. That means all these entity sets which we developed, these entity sets must be converted into relation schemas. To convert into relation schemas, we need to develop physical model. Physical model means about which actually the data has to be stored, physically stored. The associations are different. That physical tables. We will we will use the word as a commercially as a tables. So the table development is going to be done from this physical model. So we need to develop tables for course, student, basically student, course, program, lecturers. These are the four basically. From this, again committee table will be there, committee lecturer table will be there, which lecturer belongs to which committee and which lecturer is teaching a course, lecturer course relationship related table will be there, and which courses are prerequisite, that table is there. Course registered for by a student, one more table is there. These are all related to academic relations actually. So that's why 1, 2, 3, 4, 5, 6, 7, 8, 9. Physical model means you observe what is difference between physical model and logical model. In the logical model, I have given only the course or whatever it may be, entity set only or relation name only. But we have given what are the attributes, what are the characteristics of or data types of the respective attributes. You observe here course. Course is having program under which course as well as course title is there. Okay. And we defined what is the primary key, what is a foreign key also. Course ID is constituted as a foreign key here. Here it is going to be course ID is a primary key actually. Similarly, student ID is a primary key here. Student ID is a foreign key in case of course registration. So here we are defining all of the attributes, which attributes are required and what is a primary key, what is a foreign key for each course was considered here. In addition to this, we need to store details about the schools, campus, faculty, sports and club details. All these details have to be stored now. So that's why the respective attribute names as well as which attribute is considered as a primary key. These are the things are specified by us actually. Now school name is there. That is the primary key, and campus and faculty name are foreign keys. You consider sports. Sports belongs to club now. So that's why sports name is a primary key, but club name is a foreign key to which it belongs. Club belongs to campus. So that's why campus name is foreign key, club name is a primary key in this reason. That means here in case of physical model, we identified what attributes need to be stored, which attributes need to be stored. And among them, which is a primary key, which is a foreign key, based upon the relationships or associations we identified already. So this is the way we are going to develop our schema. This is DB2, but even SQL also similar. A slight variation is there in case of SQL. Only in certain cases, but normal cases it is not there. Create table, same structure is there. Create table, table name and attribute names are there. So that's why we will use the same attribute names here actually. So various tables we identified. Now all these tables, that is physical model, how many tables we identified? Those tables have to be stored by us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 tables we identified. 14 relations we identified actually. So these 14 tables we have to create and together we will consider it as a university database. Under database, multiple tables and multiple sequences, etc., etc. will be there. Programs, procedures, of triggers, all of them. Together we will consider it as a scheme, university schema, database schema. Now we are considering here schema generation, implementation by using our SQL here. The create table, we are creating campus, faculty, school, program. You observe, I'll explain one. The remaining things are similar. Campus name, campus address, district and bus number. Which bus is running to that particular campus from the city. Primary key, what is that? Primary key is campus number. And not null, because campus name should not be null. We are putting a constraint. These constraints are also specified in this create table. Actually, you observe all other things also. Faculty name is not null, and primary key is faculty name, so it is not null. And you observe here references, or you observe school actually. School consists of some, school is going to be belongs to some campus, right? And also school belongs to some faculty also. So that's why here school is having school name, campus name, faculty name, and school building address. And what are the primary keys? School name is primary key, whereas campus name and faculty name are referred keys. That is foreign keys. So references, same. The schema definition, how we are doing is, you can do in SQL also, you can do in any of the query language according to the syntax. Once you identified your logical schema, you can develop your schema in a respective language. Like this, by using all these things, we created various tables. You observe course student table, one more example. Various tables are given here. So course student means it's a registration. Course is in a one independent table, student is in another independent table, right? So you observe here, here we have written student is a table having student ID for which program he or she registered, and student number, and student date of birth, and various types of things yearly, and what is primary key. In this student, primary key is student ID, and student is registered for a program ID, no, joined in some program, no, so that's why program ID is a foreign key. Similarly, course is having various courses, and each course is under certain programs also. So that's why course ID is a primary key, observe here, and program is each program consists of multiple courses, no, so that's why program ID to some program it belongs. So that's why program ID is a foreign key here. Some courses maybe belongs to multiple programs also. For example, I like certain mathematics paper related to some engineering programs, as well as related to some sciences, mathematical sciences programs also actually. So that's why here we are using program ID is a foreign key and course ID is a primary key here actually. Now these two are going to be, student is going to register for some course, no, so that's why this is the course and student table. This course and student table consists of course ID, student ID, right? And for in which year, which semester, and also completed. Initially grade awarded is not there, but once completed, that grade is going to be added to that particular. So what is primary key? Combination of student ID and course ID is the primary key. Individual are constituted as a foreign keys with reference to student table as well as with reference to course table independently, right? So like that we able to create multiple schemas actually. Once this database schema is ready with us, we can do any type of application programs, and we can write multiple interactive queries depending upon our need. I'll discuss some queries here. List all schools are located in Toronto campus and sort them by school name. So that's why list all campus. So list all schools located. So schools located means school name is required. So we are considering select school name as a school name from school where campus name is Toronto campus ordered by school name. Simple query. Where the data exists, school name I need to get. So data exists in the school relation and school table. From school table I am taking data and school name is outputting. And what is the constraint? Horizontal, here we are using select operator, and here we are using the project operator. List all programs provided by the science faculty. Science faculty means we have to list all program, no? So program are going to be as a P dot program CD as a program code. Where the faculty will be there, science faculty is also there as well as program is there. So I'm using program and P. Both are various. Same table I'm using as a self join. self join consider P here. So program as P and inner join I am using as a self join only. S with S on P and F on P. That means we are using joining on the school as well as we are joining on F. Where F name is equal to science faculty. So self join we are using, that too we are using inner join. We discussed already inner join and outer join are going to be represented by using various formats. Maybe I can use directly word or I may use plus, minus, etc. also. I explained all those things at the time of discussing SQL query operations. And give all names of the lecturers who are the members of the committees and sort by their name. Who are the members of the committees means select a distinct L. lecturer as lecturer name from where the data will be stored in the committee lecturer relation actually CL, and we are joining lecturer and committees so that we will get the all lecturer names involved in the committees actually. Like that, various queries are going to be introduced here. So list all supervisor names, name of the lecturers they manage. So that's why here again, as I told you, self-join. Because we have to consider join our lecturers with themselves because one of the lecturers is considered as a supervisor of that lecturer. No? So that's why, like we discussed some of the queries in the employee table related to manager, similar to that. Give all the lecturers who are not members of the committee, then not previously third query is there. Instead of using in, we will use not in. It is going to be considered as a subquery was considered. Student staff ID as staff ID from lecturer where staff ID is not in, where it is not, select a distinct staff ID from the committee lecturer. So if it is not in this particular list, then we can say it is considered. It is a small subquery was considered in this example actually. Like that, we can write various queries according to our need based upon the discussion we considered, based upon the specifications and syntax and for facilities available in SQL in various lectures of this course. We can write queries also. And also depending upon our need, we can write an interactive application also consists of GUI based database application can also be developed by us actually. So thank you. This is a small effort to make you understand how to convert our requirement specifications into a database actually.
Like, share and subscribe. Hit the bell icon for more updates.